Today we're going to look at 2005, question 5, part A. Alright, so we have three smooth spheres, P, Q and R, smooth horizontal table. Okay, and they're identical, so the masses are the same. P hits Q, Q hits R, what happens to P and Q? So, let's draw this out just so we kind of get our bits clear. Not the most horizontal tables, but it'll do the trick. There we go. Okay, so this is P, Q, and R. So we start out here with P moving at 2 meters per second. And these two are stationary. This is stationary and this is stationary. All right. Now the key in this one is we have two collisions. We have P hitting Q, and then we have Q hitting R. All right. Now, what are we going to do in the end? They want to show that P strikes Q a second time. Well, essentially, P is going to hit Q, it's going to slow down. Q is going to hit R, it's going to slow down. And we need to know that the final velocity of P going this way is greater than the velocity of Q. Once this is going faster than this one, it's eventually going to catch it up and it's going to hit it. Okay, so we need to show that VP is greater than VQ2, and it's 2 because it's going to be the second collision. All right, that's the goal. So, collision 1. Okay, oh, we also know that E is 3/4. Okay, again, I like to write everything down in the diagram so I'm clear what I have. Now, collision 1 is P into Q. All right, well, let's see what we know. Our initial ones, so UP and UQ. Well, UP is 2 and UQ is 0. That's fine. VQ1, all right, because we're going to VQ2 in the second collision, is unknown, and VP is unknown. Okay, I'm going to need both of these guys. So, with all of these questions, we're going to run at two different stages. One is with Newton's Law of Restitution, and the second, Principle of Conservation of Momentum. So, Newton's Law of Restitution. Well, that basically says that VP minus VQ over UP minus UQ equals minus E. Now, an important thing to note in this one is it doesn't really, don't worry about the order of these guys, okay? You'll see this in the book sometimes, V2 minus V1 and so on. Once you're consistent, if it's VP minus VQ, it's UP minus UQ. If you flip them around, all you're doing is multiplying everything above and below by -1, and that's completely fine. So just be consistent with what's the first term and the second term, and it all works out. So let's put some numbers in. Well, VP minus VQ1, just be right about this, all over 2 minus 0. And that equals minus 3/4. So what we know here is that VP minus VQ1 equals minus 6/4. Okay, so equation number 1. I guess simplify that down to minus 3/2 if I wanted, but it's okay for the moment. Second way we're going to look at this one is the principle of conservation of momentum. Now that is normally M1U1 plus M2U2 equals M1V1 plus M2V2. Okay, you should absolutely know this. Now in our case, because they're all identical, all of the masses cancel out. So I'm just left with U1 plus U2 equals V1 plus V2. Okay, so that is 2 plus 0 equals VP plus VQ1. Okay, so VP plus VQ1 equals 2. That's my second equation. 1, 2. We'll combine these. We'll basically say 1 plus 2. So we have VP minus VQ1 equals minus 6/4. And then VP plus VQ1. And the reason I was 1 plus 2 is that these are going to cancel out. I might sometimes, it has to be 1 plus 2 times 2. And that is going to equal 2. Add them all up together. They go 2VP equals 2 over 4. All right, so VP equals 1 over 4. All right, so that is a very useful piece of information, 1 over 4. Now we are going to draw a little bit of a line here, and I'm just going to use the top little bit of the page here to finish this one off. If VP is 1 over 4, we'll just, this one looks a bit nicer to use, so I end up with, using equation 2, 1 over 4 plus VQ1 equals 2, so VQ1 equals 7 over 4. All right. Now, meters per second, but they haven't asked us to show that, so I'm not going to worry about that for now. So there we go. And I'll put this in my little table here, 7 over 4, just so I know it. It's all handy. Now, collision 2. This is when Q hits OR. So, we need new data for each collision. So what we're going to have is, now we're going to have UQ, which is equal to VQ1, which is equal to 7 over 4. Okay, just be careful with your terminology here. If you're writing this as VQ, yeah, I'm going to mess over here. Because over here we have VQ2, and that's an unknown. UOR equals 0, because it's the rest. VOR is unknown. All right. And we actually don't even really need to know VOR, so that might make life a bit easier later on. Newton's Law of Restitution, step 1. So, again, just to write this out a little bit clearly, we are going to have VQ1 minus, VQ2 minus VOR all over VQ1 minus UOR equals minus E. Never underestimate the power of just laying it out to avoid silly little mistakes. You can see I nearly slipped on that one there. So, VQ2 minus VOR all over 7 over 4 minus 0 equals minus 3 over 4. So VQ2 minus VOR equals, I'm going to bring this up, and that's going to end up being minus 21 over 16. Yeah. All right. Call that equation 3. Now we'll do our principal consummation of momentum over here. So you can squeeze it all in nice and neat. So we know from before the masses cancel out, so it's just the two initial velocities equal the sum of the two final ones. So in this case, it is 7 over 4 plus 0 equals VQ2 plus VOR. Now, this is lining up really nicely because I don't need to know VOR, so I'll just kind of cancel that one out. So we'll just call that equation 4. So we're going to end up with 3 plus 4. So that is, just put everything on the one side here, VQ2 minus VOR equals minus 21 over 16. VQ2 plus VOR, it's up here, equals 7 over 4. Bump, bump. 2VQ2 equals, now I'm just going to convert this into a common denominator, so that's 28 minus 21 all over 16 is 7 over 16. So VQ2 equals 7 over 32. Now, show P strikes Q for a second time. So I wanted to show that VP is greater than VQ2. Well, VP equals 1 over 4. VQ2 equals 7 over 32. Okay, and just if you need to do this in your head, equals 8 over 32. Therefore, VP is greater than VQ2. Therefore, P strikes Q. Okay, so again, let's get clear in the beginning, and as we work through these, law of restitution, principal conservation momentum, and we just bring things out bit by bit. The key in all of these ones is every collision gets its own table. Otherwise, initial velocities become final velocities, and it all gets a little bit messy.